Okay, let's take a look at doing a restore. And the point I want you to really understand here is that recovery model and how it changes your options. I did a few backups, and in VentureWorks, all I did was I went over and I did a backup. And first I did a full, then I did a differential, and then I did a transaction log. And you'll see them. So now I want to recover. So I'm going to right click up in here and I'm going to go into tasks and I'll call recover. I'm going to recover a database. And we'll select that, and here you can see I did a full, as I said, a differential, and a number of transaction logs. Now I did them real close together, but we'll click timeline in here. And what I want to do is, by default, it'll say to the last backup, but I want to go to a specific date and time. The reason I'm doing that is, say I know what time the data became corrupted. I have a good suspicion. I'm going to switch this over to hour to spread this out some. And now we can see it within the display. And here's where I am when I started this. And if we come through and take a look at it, if I move this back in here, you can see the display changing. So I can come back up and let's say right up in here, what's going to happen, it's going to apply the full, then the one differential. And if you'll notice, I have a number of differential backups, but we're only showing one over in right here. The reason we're only showing one is the last one picks up the changes from the last full. So now I'm going to recover over into this point in time. So I'm in there at 254. Let's back it up a little more just to make sure we're seeing something obvious. 252 sounds good. We'll say OK. You see this says 252, and I'll call OK. And it's done the restoration. Let's do this. I'm going to right click in here. I'll go tasks and we'll call backup, and we're going to do a transaction log, and we're going to say OK. Now I'll right click again and we'll call restore database, and there's my latest log. And now if I come over to timeline and go down to a specific time, switch this down to hour so you can see it a little clearer. So I can see this information here. And now if I drag this on across, a tail log backup will be performed. I know you can't see the color code because the times are so tight, but it actually turned light green. Tail log is the tail of the transaction log. It has the latest data in it. So what will happen here is the first thing SQL will do is back that up. So it's got that to apply so that we don't lose that data in here. Now let's look one other thing. Let's cancel out of this. VentureWorks, tasks, backup. Let's do a differential. And we're going to say OK. Take a look again. Can you figure out what's going to happen? Database. Ooh, you see the logs are gone. Why? Well, the differential picked it up because of the recovery mode I'm in. Okay, let's cancel out of that. And at VentureWorks DW is in, I hope, simple recovery mode. Okay, we did a couple backups in there just for this demo. So tasks, and I'm going to call restore database. And you see there's my full and my differential. And now when I go into timeline and switch it down to hour and move it on across here, there's my full. And as I come in here, there's my differential backup, right? So the last spread that I have in here. And I notice I have no logs in here. Why? Because I use the simple recovery method. So if I select specific date and time, there we go. And I drag this on across 245 and I say OK to 245, and now I call OK. I've done my recovery and I backed up before that last differential because, say, I knew that I had a data corruption at that time. So you can see the full recovery model allows much more robust, much less chance of actually losing any data than the simple recovery model. And you also saw how my backup options changed. I can't back up my transaction log. So again, when you're looking at this, what you really want to dictate is you want to know how much data can I afford to lose. That'll dictate your recovery model. And you decide how much data you can afford to lose by how much will management allow you to lose and how much money do you have. So then we go either simple or for mission critical, we're going to go full period. Sometimes you have to protect management from themselves. There's your doing a recovery. And of course, you can do all of this with T-SQL. I just did it in the SQL Server Management Studio because it shows better. Okay, let's take a look at the import and export wizard. Now, word to the wise about this tool. If it happens to throw an error, it does not attempt in any way to clean up after itself. So you have to investigate what's actually happening there and then go back in and fix and come back through and run your error again, which can take some time. Experience speaks. Okay, let's run it. So let's use our friend AdventureWorks. Well, right click, and of course this is a task. Zip on down. Now you'll notice that this can run either way. That is, I could run the wizard and say import data, or I could run the wizard and say export data. It really doesn't matter. It's just one is a flip of the other. So, but I'm going to export the data. Here's the splash page, which you should read in detail. Just kidding. I've never actually read it. And we go next. And now we want to pick up our connection provider. So as we pull this on down, we can take a look at all this information down here. Now I want to use SQL Server Native. So I'm just going to select that, and you see the way the image changed up in here. So now it immediately picks up SQL Server. Let's go back and look. Compared to this. Now here, if I use this, then I have to come through and configure all this information, which depending on what you're doing, you may need to do that. So here we'll go SQL Server Native. The server name is SQL1 because that's what I'm on. And I picked AdventureWorks. Now, I've already run through this wizard once, and normally when you start this is going to come in and it's going to say default. We'll just leave it at AdventureWorks. That's where I want to get the data from. And I am going to use Windows authentication. I could use SQL because if you watched me install, I put SQL into mixed mode, meaning I have both Windows and SQL authentication available. So now we'll go next. And destination. I'm going to dump this back into SQL, so I'm going to say SQL Native Client. And what server now wants to know where I come into, and I can just enter a dot. The reason I can enter a dot is a dot, or a full stop if you prefer, period, resolves to the IP address 127.0.0.1, which means current or me or localhost. They all resolve the same. So that's the same as typing in SQL1. Now, where do I want to go? Well, let's do this, which I think is really cool. We'll go new, and let's give it a name, and I'm going to call this export example. Okay. And here you could set up your different information that you wanted for your wizard. You can set up the initial size log, etc. So this is fine. We're just going to stick with the as is, and we'll say okay. And now we'll go next. Now it's asking, this is fairly important, this write a query. Let's show you that. And we go next. Now you can input a SQL query by typing it in. This is really a pretty good way to go. That said, please don't use this interface to type your query. Go to SQL Server Management Studio and open a query, create your query, and test your query then until you're sure you have it, and then save it somewhere. And then just import the query by using your Browse button, locating wherever you put it, and bring it in. The reason I say this is a good way to go is because you can be extraordinarily granular. You have all of the capabilities of T-SQL doing it this way. But if you're like me and lazy, we're not going to. We're going to copy. Next. So pick what you want to copy, and let's just grab a couple tables. These two are fine. Now down here we're going to say preview, and that'll give me a chance to look at the data as it's coming in. Okay, so I can see the different stuff and we'll say okay. And now if I select edit mappings, this is where I could come through and change some kind of a mapping I had in here. If I'm coming from one database over into another that has a table in it that perhaps has columns that are of different data types, different sizes, etc., then I can map it in here. I would also suggest that if you're running into that, this is not the tool for you. Instead, use SQL Server Integration Services, which we looked at earlier, and of which there is a video on lynda.com online library, to create an SSIS package and do your imports and exports from that, because it is much easier to do sophisticated transformations in that technology than it is here. Okay, enough preaching. So we'll say okay. And I'll go next. And now run immediately or save the package. And we're going to run it immediately, but another little my opinion. Save package to SSIS. If you select that, I strongly suggest you save it into SQL. Back in the day, we used to save packages a lot of times into the file systems, and we really don't like that much anymore for a number of different reasons. So I would say save it into SQL. I'm not going to do that because we're only going to run this package once. Oh, by the way, you see encrypt sensitive data with user key. So you got all those different options, but we're not going to save it anyway. So now we'll go next and we'll call finish. And if we did this correctly, it will work. Excellent. See, here's your rows transferred. Again, the report just shows you this again. So we'll call close. Let's refresh our databases. There is export example, and here's the tables. Let's see if they're there. I'm going to right click one. I'll select top 1000, and there's all of my data. Okay. Now let me close the query so I can break the connection to the database. Right click and we'll dump it, delete, close existing connections, and we'll call OK. And we'll let that run, and she's gone, and we're clean. So there's your import and export wizard, which is very handy. I use it for simple imports and exports, sophisticated imports and exports. Again, to repeat myself, I use SQL Server Integration Services. Let's take a look at the BCP program. BCP's been around forever. If you take a look, the versions back to SQL 2005. So we've been using BCP for a long time. The reason is it's a very low overhead and it works just excellent. There are lots of different commands you can do. I'm just going to scroll down here to show you that. So you see all these different commands that we can have. And Microsoft will give you all of the different arguments. I've got a couple of files that I'm going to do in here. And the first thing we're going to take a look at is we're going to export a table with the BCP utility. And I've got this little code snippet. And if I double click it, it'll open up. And the command just says BCP. Now I'm going to export a table. When you do that, you need to give it a fully qualified name, which means here it is, AdventureWorks, which is the name of the database, .sales. The sales is the schema. And then .object, which here is the table, sales order detail. And then what I'm doing is I'm saying I'm going to output out to where, and C::code, and then the name of the file I'm outputting is bcp_out.txt. Command lines are not at all friendly, and so I would be careful. Just name your stuff with the underscores and don't use spaces. Don't get into that nightmare. So then after the .text, I have a -s, which is the name of the server, which is SQL1. So that's not -SSQL1, that's -s, and then the name of the server. -T means a trusted connection. Because I'm using Windows, I'm connected as an administrator, so that's fine. And -C is how I want it out, which is character out. So now we'll open a command prompt. And I've got it pinned down here to the taskbar, so I'll just right-click it. And I could run it as administrator, which you know is right here, which I tend to do, even though I really don't need to do it here. Now I'm going to select all of this code, Control C, and switch over to my command prompt. Command prompts are not friendly. If you haven't worked with them, you should give it a try just so you can see the suffering we used to have to do. But I'm going to go up here in the header and I'm going to right click on it and I'll say edit, paste. And there my command is in. And if I did not fat finger anything, which is always a possibility, we'll just hit enter. Zip, and it's out. So let's see what happened. Let's close this and go on over to code. There's BCP out. Let's right click it and I want to open it. Oh yeah, it's a text file, so it'll open like that. There we go. So I outputted that entire row. Pretty handy. I'll delete that a little bit later on. Okay, now let's take a look at another thing. Close this command prompt and just do everything again. Okay. Normally, we're not going to export an entire table. We're going to create some code. So what I did, I've got this BCP export with select. So you see there's a select statement in it. BCP select what? Select product ID, order quantity from, again, fully qualified name. And then the trick here is instead of saying out, I said query out, and then just dump it into another file, BCP out select.txt. And the other switches are the same. SQL1 is my server, trusted connection, character data out. So we're going to leave that open because we're going to run that code. By the way, when you're writing this code, write it in T-SQL. Don't actually ever try to type it into the command prompt. You'll never finish. And then just save it as a text file. Okay, so let's go ahead and open the command prompt again. And I'll just open it the normal way here. Now, by the way, most people switch over to just the C drive, but you can do it just fine from where we are right here. So I'll select everything, Control A, Control C, get it in the memory. Switch over here. And again, I'm going to paste. And as you see, it executed immediately. And let's see if it worked. Close this. Code. There's my BCP out select. And if I open that, you can see I outputted product ID and order quantity. Okay, so now we got it out. Let's get it in. Go back over to here. And now we're going to use the file that I erroneously used earlier. But to get it in, I'm going to need a table. So we're going to switch over to SQL Server Management Studio. And I'm going to open the query. I could have just double clicked it and she would open, but we'll just do it this way. So I'm in here and I'm looking for the query, create table for BCP import. All right. So here it is. This is as basic as you get. Use AdventureWorks. Let's just make sure that I don't already have that table because, oh, you see there, we do. Okay, let's get rid of it. And I've got this little drop table statement. We'll execute it, do that. Okay, now let's recomment out this code. Now I'm going to execute this and create the table that I just dropped. And let's make sure it worked. There it is. Cool. By the way, how I came up with this is, I exported order quantity and product ID from sales.sales order header. So let's go down and look and see what I did. Sales.sales order header, and I exported 2 columns, order quantity. There it is, order quantity, and you see that's a small int. That's where I came up with this. And then product ID, and that's an int, but I changed it to null. Word to the wise, when you're importing this, you'll throw all kinds of constraint errors when you're bringing this information into the tables if you have constraints on them, primary key violations, etc. So this is more difficult than it looks. And sometimes you have to go through and actually dump or delete, alter table, delete the constraint, and then dump your data in and then re-add the constraint back. Okay, so now we have that table, and that's where I came up with this. I'm matching what I came across. Now let's let BCP work, hopefully. Let's drop this down, and let's say BCP in, which is the one I did have, and we'll copy it. Open a command prompt and paste. Execute. Let's see if it worked. Let's switch over to SQL Server Management Studio and showing you that. Let's get out of that and move up to the top. Get into our big DBO. Right click, select top 1000. There we go. So I've exported and I've imported via the BCP utility. Now, real quick, if you noticed, BCP commands are case sensitive. As I've said earlier in this course, pretend everything you do is case sensitive, then you never get in trouble. Another thing, if you're copying really large amounts of rows, in the tens of millions, etc., then you really kind of want to break it into smaller chunks. And the way you do that is, again, you saw I did mine with a select statement when I brought my data in. So I can write the select statement and do a where clause so it'll limit by dates or whatever it is I'm doing, and I can bring them in then in chunks. Also, I already mentioned to there, when you're bringing your data in, you need to be cautious of your constraints. So you'll try it and see if it throws a constraint, PK violation, etc. And BCP will do no help at all for you there. You just have to go in and figure out what went wrong and go from there. But there's the BCP utility. Been around a long time, works really well, and is really fast. So, what is an index? Well, the standard metaphor are a phone book and a Rolodex or a library index card. Anyway, think of it this way. So I have a collection of 3x5 cards and I shuffle them up and I dump them down, and now I want to find somebody. What you have then is my desk. What I should have done was taken them and put them in order, so now I can find them much quicker. And that's what an index is. I think everybody understands that. Now, the SQL will always use an index if it's available. So think this over again. Let's say I have a table of data, and I have 100 rows in there, 1,000 rows, I don't care. And there is an index that has this information sorted. Will SQL use that index if it's available? And the answer is, of course, no. SQL may use the index. The query optimizer uses an algorithm to look at the query, then to look at the data and makes the decision if the indexes are the most optimal way of retrieving the information. Sometimes, actually many times, SQL will make the decision that it's just easier to scan the entire page where the information is stored or the extent and retrieve the information that way. So, in that situation, your index didn't do you any good. What is the most important thing to aid indexes? It is update statistics. SQL keeps statistics on the efficiency of indexes, the changes in tables, etc. And SQL uses those statistics to make the decisions with the query optimizer that I just talked about. As I recall, the SQL statistics on an index on a table are updated whenever the table changes by 20%. So a 20% change will fire and update statistics. So that said, that may be just fine and you can change that. But the most important thing are that the statistics are current. The types of indexes. I happen to like two different taxonomies, taxonomy by storage and taxonomy by column designation. So by storage, heap. When you first create a table and dump information into it, it goes into the heap, just like my office table that I'm looking at here, with stuff just laying all over it. That's a heap. By the way, heap storage should almost never keep your tables in heaps. Occasionally you do that if it's a temp table and that kind of thing. A clustered index. So now a clustered index, we take the information and we reorganize it, and it's now in a logical clustered method. So we use the key to come through and organize it that way. Non-clustered indexes are built on top of a clustered index. So a non-clustered index would have other columns in there, and it has pointers into how to retrieve the data off the clustered index or into the table itself. Column store indexes, that's a little bit beyond scope here. A column store index is an index that was first in SQL 2012 and enhanced in SQL 2014. Column store indexes are based on in-memory databases, and that's the Vertipack engine. It's the compression engine. So what we do there is we take these indexes, and if they have the same value, then we shrink them down and put a pointer in. So that said, there's a lot of limitations currently on column store indexes, but be aware of them that you are going to become more and more common as we move to in-memory databases. XML indexes. An XML index is a way of indexing an XML document. I'm a fan of XML. I'm not crazy about XML indexes, though. They can be really slow in their performance because they have to do what's known as shredding the XML document. So anyway, you can really get performance problems within XML documents. A spatial index. A spatial index is a special type of index that's designed for spatial data. Spatial data gives me the ability to draw maps, and I can index based on that. Now, by column designation, the primary key. All right, so when I create a primary key, it creates a clustered index. And the primary key then now is the key that we use to enforce uniqueness in our database. And our primary key is used for normalization. And normally we would assign a primary key to a table. By the way, if you're not familiar with the concept of database normalization, please pause immediately and write that down. And then as soon as you're done this course, go over to lynda.com library and look up normalization for databases and make sure you are familiar with normalizing a database into third normal form and also denormalizing a database. A unique key is very similar to a primary key. The difference is a unique key allows nulls, where a primary key does not. Included columns. An included column index is one in which we have a number of columns, and normally we would create an included column index because quite often your users are running queries where they have a certain amount of columns they're selected, and it's the same over and over again, and we're going to take those same columns, put them into a included column index, and that's then also referred to as a covering index because that index has the columns that they search on. So if we have a table with 50 columns in it and there's 4 of them they search on, then we can create a covering index and it will speed up those particular queries. Partitioned indexes. This is an enterprise feature. We can take a table and break it out. This is very common in data warehouses, so we break apart large tables. So the old stuff hardly ever changes, so we leave it over there and we store it in a certain location. And then we have different indexes by different dates. And say that we are constantly loading information into the current month. We can create a partitioned index that will only contain the information for that month only. Filtered index. A filtered index is one that has a where clause, and we use that once again if we're running certain indexes that have where clauses. Index compression is a relatively new concept for in-memory databases so that we can compress the index and take up less space in memory. Let's take a look at the concept of creating indexes. Now, the first thing we're going to look at is the Microsoft documentation. So here we are in Create Index, and you see this versions. I probably mentioned this before. Always make sure you're looking at the version that you're working with because all of this stuff adds features and features are deprecated as we go along. So you want to make sure you've got the right thing. There's a lot of information here. Here's your basic syntax. And as you can see, as I'm moving down, there's lots and lots and lots of information. This is an extensive page. There are books written just on indexing that can run into the hundreds of pages. This is an involved subject. So anyway, this is really an excellent page to come through and read. It will get you started on a more in-depth understanding of indexing. So let's close that out and let's switch back over to SQL Server Management Studio. And what we're going to look at is what I want to do is show you the design of some indexes in AdventureWorks, which is well done. So the first thing we're going to do is we're going to open a new query and we're going to allow SQL to help us. Insert snippet, double-click index, create an index basic. All right, there's a basic index. Wasn't that fascinating? Create index IX underscore. This is just a naming convention that some of us follow, some of us don't. So the table name, column name, but you see how informative that is? IX tells us it's the name of an object, and then it's table, and then it's column. On whatever table and whatever column is on the index. So let's look at another snippet. Create unique non-clustered index on table name, etc. Remember, a unique index is one that allows nulls, but it is unique in that it will allow a null. And frankly, if you're not familiar with that, why we can allow multiple nulls, because null is not equal to null. Null can be in two states, but that's beyond the scope of this course. Okay, so non-clustered index, and then its name, etc. Cool. All right, so that's very basic. Now let's look at, I've got a table open here, human resources employee. And from the bottom, the first thing we have down here is the primary key, and it is clustered. It's a primary key index, and it creates a clustered storage, meaning the data is resorted according to the primary key. Now moving up, if you'll notice, all the others are non-clustered. Some of them are unique, some of them are non-unique. Let's think that through for a second just by observing the indexes. So here I have logon ID, and this index is unique because we surely do not want two instances of the same logon ID. But it is non-clustered. It has to be. We can only have one clustered index. National ID number, same logic. Row GUID, same logic. Now, organizational level is non-unique because as we're inserting employees, many of them can be at the same level. So it's non-unique. And the same thing with organizational node. Are we happy? Let's look at the code. First thing we're going to do is look at the PK, right-click, script index as, create to, new query editor. You can ignore most of this stuff, but it's primary key clustered. That's add constraint. Primary key is a form of a constraint. And there's your column, business entity ID, sort by ascending. And then here's your different options, which you can look up in the page that I showed you. One of the more interesting ones is this pad index equals off. What that does is, if you're doing a more sophisticated design and indexing, and you know that you've got a table that's going to get a lot of inserts, then you can pad the index, which means leave empty space. So it's easier to do inserts. Now, well, why don't we always do that? Well, because it's bigger. So you got that. So there we are. Now let's take a look at some of these other indexes. Here's this non-unique, non-clustered, right-click, script index as, create to, new query editor. Okay, non-clustered index, the index name on the table, organizational node ascending. Okay, here's the way non-clustered indexes work. Why they're so fast. So if we're doing a search on a large table where organizational node equals something, so we've got that in here. Now, normally that non-clustered index would be used by the query optimizer because the query would be, I'm saying a selective query in here, so we're looking where organizational node equals something. The reason this is fast is all non-clustered indexes contain as part of their self that clustering key. And remember, well, the clustering key is the identifier to get me into the unique row. So this index, organizational node, will have with it all of the information of how to get over to the primary key, which points me directly into the row to retrieve the information. So in that case, this non-clustered index would be highly selective. Selectivity is a very important concept. And we would use that. Maybe. I say maybe. So what if there's only 4 values? So we've got 10,000 rows or whatever, and there's only 4 values in that organizational node. Then there's no sense in using the index. We might as well just scan the whole table. We have to scan it anyway. to retrieve all the other data that we're bringing back. So again, the query optimizer makes those decisions, and that's a decision you have to make when you're indexing this stuff. Okay, let's take a look at one of the unique non-clusters. Script index as, create to, new query editor. Okay, same thing. It's a unique index. It's non-clustered. There's its name that's on the table. Row GUID, and it's ascending. So if we're coming in and we're looking for a range of row GUIDs in ascending orders, then this index would be used. So there's pretty much the philosophy. The primary key is your number one decision, and then after that, how you decide on these other indexes you're creating is you have to understand what the users are going to be asking, which comes from the experience with the database or sitting there with the users and saying, well, how do you want to query the system? But there's indexing. Understanding execution plans. Let me tell you this, when you are tuning SQL, that is, you're looking at your queries and trying to make them operate faster, one of the first things you're going to want to take a look at is execution plans. When I say one of the first things, if you're starved for physical resources, then execution plans aren't going to help you much. So the way SQL processes a query, when you submit a T-SQL statement, select whatever, the first thing that happens is the SQL is parsed. So if you fat-fingered something, you misspelled where, or whatever, then we're going to pick that up immediately. We'll throw an error, and we're not going to waste our time, and we'll wait. So if it passes the parsing step, we go into binding. Binding is when we do name resolution, and name resolution will come back now and look over at the objects and make sure it can figure out what actually schema.table is, or whatever it is we're trying to tie into. So now if we passed parsing and we passed binding, we go into query optimization, which uses an algebraizer tree. Some word, huh? Algebraizer? You can frankly look that up, and Microsoft has a white paper on it where you can come in and they'll give you a little bit of information on how that works. When I say a little bit of information, it's proprietary. They had gaggles of PhDs work on this because it's extraordinarily sophisticated. Then we come out of the query optimizer with an execution plan. So the query optimizer does not consider all possible execution plans. It just considers a subset, and it puts forward the one that it thinks is best. So at that point, when we have a legal T-SQL query up in SQL Server Management Studio, we can look at a estimated execution plan. Cool. Then we hit F5, we go, the query is executed, and we get the query results. By the way, after that's done, we can look at the actual execution plan. So there is a logical and a data flow of execution plans, and they go opposite to each other, as you'll see. I've said there is two types of execution plans, estimated and actual. The estimated is the one that runs before the query, and you might say, well, why not just use actuals? And it's because of this. A query may be long running, several minutes and longer. So an estimated plan will give us the opportunity to optimize the query before we actually have to suffer through and let it run to see the actual. Execution plan reuse. SQL is efficient, meaning it's not going to make the same estimate twice. So we take the estimated execution plan and put that into a plan cache. So if you rerun the same query again, then that phase, the execution plan or the query optimization, is already done, and it will reuse that. Here you go. Here's an execution plan, and you see we have a logical flow and a data flow. The data flow runs from right to left, top to bottom, and the logical flow runs the other way. Now, it's important to look at the thickness of these lines. If you'll notice, some are thin and some are thicker, and that's a reason. That shows you the amount of data that's flowing on across. And if you'll look, you see the percentage underneath. And what we're doing here is this is either the estimate or the actual cost of the query. And these little icons are called operators. And so we can look at, say, on the very bottom there of the green arrow, you see clustered index scan. That costs 20% against the entire cost of the query. So moving on across, we can see the big cost was the hash match inner join. That might be something we might want to take a look at as far as we did that. Then again, if the query executes within the amount of time you're happy with, then you've got enough work down the road you go. And then we do a sort, and then notice finally the select, moving from right to left, is nothing. All the work's already been done. Here's your estimated and actual plan. On the left is estimated, on the right is actual. You cannot tell by looking at a plan whether it is the estimated or the actual. Sometimes there's slight differences, but you can't tell. And you might wonder why there is slight differences. It's because when you run the estimated, you could be fooling around for 20, 30 minutes before you actually execute the query. In that time, something may have changed. Statistics were updated, etc., etc. So the estimated plan may be at variance with the actual plan, and you're going to run into that. Let's take a look at some execution plans, and we'll open some samples. File, open, file. I want to be in the chapter 7, and I want to open sample execution plans, and I've got a number of SQL statements in here. So the first thing I'm going to do, let's just select the first one, which is a simple select everything from the database log. Let me execute it, F5. And I really didn't want to see that. So I'm going to select that again. I just wanted to show you that it would execute. And up here, you'll see this display estimated execution plan, or Control L. And if I click that, here we are. So here's what the query optimizer has chosen. It's going to do a table scan. And as you see, it does the output. 100% of this query's cost is in the table scan. As you hover over this, you'll get a pop-up of the operator, which will show you more information. You see the physical operation and the logical operation. Operators have two different components, a logical and a physical, and sometimes they're at variance. And then we have other information. You see it's coming in off the row store, and estimated number of rows, 1,597, row size, ordered false. That's something, frankly, when you're going in and looking at indexing, you might want to take a look at. Here it doesn't matter, but when it ordered's false, sometimes we can change that to true and come up with a more optimal. So now let's do a little select. Select everything from the Human Resources Schema department, and again, Control L. So there we go. Now it's going to do a clustered index scan. So from Human Resources Department, and I've got that open right here, indexes, there's my clustered, it's scanning off of the primary key here, clustered index scan to retrieve everything because the clustered index has a pointer to all of the data. Okay, now we're going to select just the name, select name from the department. Control L makes life easier. And now we did an index scan non-clustered. So why did it do a non-clustered? We're retrieving the name. Let's come over here to our indexes, and we see we had the name down here has a non-clustered index. So that's more efficient than if it did it off of just a table scan, etc. Now we're going to be selecting the group name and Control L. Now the group name has switched back over to the clustered. Well, why? It's because group name, the column, is not included in any of the indexes, either not in the clustered or the non-clustered index down here. Now, this is the one that's going to be fairly interesting. Now we're trying to select the carrier tracking number from sales order detail. Where? Well, now we have a where clause. Order quantity is greater than 19. And watch this. This is, in my estimation, pretty cool. Okay, so clustered index scan, select missing index. Create non-clustered index. SQL is trying to help you with this. It's telling you this would be more efficient if you had a non-clustered on whatever it is we're searching for up here, carrier tracking number. Impact 84%. That is, this query would be more efficient by their estimation down there if we created this index. So we should run out and create it, right? Wrong. Why? Well, indexes take space. How often do you run this query? This is an indication, but you gotta keep looking. You gotta use other technologies, data management objects, to watch what's happening in here to see if you should create an index or not. And I've got another query in here that has a large execution plan. This is just a query that I threw together, and we're going to select everything in here and Control L it so that we can see a bigger execution plan. Let me close Object Explorer. So here we go. And as you see, I'm going to drag all the way across here. And again, here's my data flow. And if you notice the different sizes, and as I hover over, I get my tooltips. So here's an index seek. Seeks are very efficient. And here's an index scan. So we're running on across. Now we're doing inner join, very efficient. Now I've got parallelism in here. What that means, frankly, is we're breaking the stream apart because I've got multiple processors, so I can break the stream apart and take advantage of parallelism. Now we're into a bitmap create. So it's helping itself by creating a bitmap. And now we have another clustered index scan, and we're coming up, and now we're joining output into the hash match. Coming down, we've got an index scan, again, a parallelism break, enlisting another processor, coming up, bitmap, parallelism, bitmap over in here, very efficient, C0, 1%, 0. Inner join, hash match, 5%, okay, cool. And now my sort, look at that sort. So the sort operation is costing 50% of the entire cost of this query. So that's something we might want to investigate. And now we split, and now we bring everything back together, 17% and the 0 down here. By the way, you see all these parallelism? That means the optimizer did look and said, well, I've got multiple processors available, and it's more efficient to break them apart in its estimation here and then have to rejoin them. So that doesn't necessarily mean it's true, but it's stunningly accurate, actually. Now here's a little piece of trivia. The query optimizer was updated with SQL 2014. The last update of the query optimizer, if memory serves me well, which I think it does in this case, was SQL 7.0. So all the iterations since then up to 2014 did not change the query optimizer. So cool, huh? By the way, that does matter when you bring in other databases. If you want to use the new query optimizer, you have to change the compatibility level of the database. But it's really easy to do. It has other ramifications too. So there we go. There's your execution plan. An excellent place to look and see what's happening and how perhaps you should reindex your database. Let's take a look at the Database Tuning Advisor, which is certainly a tool I would experiment with. The first thing we have to do is we have to turn on SQL Server Agent. As you see, I've got it highlighted here. This tool, DTA, just like many tools, uses SQL Server Agent to run jobs. So we're just going to right-click it and say Start. Are you sure you want to start it? Okay, we're good. Now, let's show you another little tool. You should never run the DTA against an existing database because we can really hose things. Let's select it. It being the database, right-click, Tasks, and we'll look at the Copy Database Wizard. Next, Source SQL, Destination SQL. Just ignore that. We're fine with that. We're going to detach and attach method. If you're going to use a live database, then we're going to use the SMO, which is slower and more problem-plagued. But we're going to detach and attach. Next, in here, and what do I want to copy? AdventureWorks 2014. That sounds good to me. Yeah, there we go. It filled it out for me, but we're going to change this to DTA, AdventureWorks 2014 _ DTA, and call next. Next, run immediately, next, and call finish. And let that execute. Doesn't take long. Close the copy wizard, and let's make sure it worked. We know it did. Refresh. There is our victim. Okay, now let's open a workload. So we're going to go into Chapter 7 and cleverly open the workload just so you can see it. And this just has a bunch of different statements in it, so I'm thrashing the SQL Server just a little bit. It's got some information in it. And you see I'm using Use AdventureWorks 2014 DTA. So if you don't have such a database, it won't work. Okay, and we could execute that. We don't need to. So now let's run the Advisor, Tools, Database Engine Tuning Advisor, connect into SQL. That is correct. And you can give it a name up here for your session name. We're not going to, but it's probably not a bad idea. So I can run it against a file or a table. Now this is fairly cool. I can run it against the plan cache. So again, if I had a number of queries I wanted to execute and they would put queries into the plan cache, I can then use the plan cache as a workload rather than just a file. But I wrote that file for you and doggone it, we're going to use it. So we're going to open workload. All right. And we can use the master to do the work. That's fine. And the target though is DTA. Okay, glancing around, everything looks fine to me. I can go full screen, show it a little better. I'll click Start and let her roll. I have hardly anything going on in there, but if you have a serious workload or a production server and you're going to use the plan cache, then this can run 30, 40, 50 minutes. So, again, it's something you want to be aware of. So what it advised me to do here, come on across, is I can go down here and you see object name, person.person, recommendation create, and believe it or not, there is a tooltip somewhere if I can get it. This is a create statistics. Create statistics, and down here it wants to do an index on the sales order, size, estimated size, etc. And here's my definition. Create non-clustered index, sales order ID ascending, include blah, 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 line. And we'll close out of that. And I can also look at these others, create statistics on this column, and we'll close out of it. Okay, now let's go and we're going to select it. So I can go into Actions, and I'm going to say Apply. Apply now. Yep. Close. So you've selected that and you've applied all of the fixes to the database that you so decided. Now, I ran through that rather quickly. In a real production database, then this would take much more time, and you want to really investigate it much more deeply. The key is workload. If the workload is really not representative of what your actual workload is, then this isn't going to do you much good. As a matter of fact, this can actually hurt you there. That enhancement with SQL 2014 of being able to use the plan cache is pretty cool. So, it's something you want to investigate. That said, this is a tool definitely worth taking a look at. Let's take a look at Activity Monitor, and that's started up on Server. So I'm going to select Server here, and I'll right-click it, and here we are, Activity Monitor. Up she pops. And this will look fairly familiar to you if you've ever used Task Manager and gone into detailed view. So I can set the refresh interval, and currently I have it 1 second. I would not normally do that, but I'm collecting it here at 1 second because we're just not doing anything with this database. So, I'm just trying to show any activity that we have. And if we click Processes, you can see the process ID, how it's logged on, the database that we're using, and more information coming across. If I have anything that's doing weights for me right here, it's going to show me my weights. And IOs, I'm not doing anything down here. I'm not doing any inputs. So she's just not going to give me much information at all. As you see, there's my temps, and the counts are all 0 as you come down, up and down. Expensive queries, this is anything that has happened. And if you'll notice, as we drill on down into, we're really looking at just queries that SQL runs internally. So if we generate a little activity, let's open a query. This is one we've used before. I'm going to open large execution plan, and we'll just execute it to see what happens. She's done. And if we switch on over here, and now we go into processes, now I come in and I see this process ID, and if I right click it and say details, there's the query that I just ran in there. And because the query window is still open, I still have a connection into my database so I can see what happened there. I can right click it and kill it. If I had a hang up of some type, I can take care of it there. And down here in the recent expensive queries down here, and now you see what's moved back up. Now my query, which was recently expensive, has moved up to the top. Again, we just haven't done much, so that's why we don't have much information in here. As far as if you were looking at a production database, you're going to see a much bigger bang in here. And of course, at that time, you want to change your gathering interval. So there's your activity monitor. Let's take a look at data collection and the management data warehouse. So under management here, I'm down here in data collection, and I'll right click tasks and I'll configure the MDW. Now there's my splash page. We'll just go in for next. And the server name is SQL1, obviously, and I'm going to create a new database to hold this. So I'm going to name it MDW. And we'll say OK. Next in the wizard. Now at this point, you would log your different logins into the database roles for the management data warehouse, which is for the administrator, the reader, and the writer. Now we haven't yet covered logins and that stuff. We cover that in the last chapter of this course. So if you're not familiar with it, you will be by the end. But right now, we're just not going to worry about it because we're logged in as the administrator, so we're going to have privileges in there. So we'll just click next and click finish, and everything works, so we'll call close. And there's my MDW. And just to show you some stuff, if I look at tables, as you can see, there is a lot going on here. This collects a lot of different information. And if I look at stored procedures, as you can see, we have just a lot of information. So this does a great deal of work. And I showed you that for a reason. And it is a very handy little utility. But it does burn a lot of memory. That is, take up a lot of disk space. So you got to kind of keep your eye on that, and see if you're getting out of the MDW what you hoped for. So now on data collection, I'm going to right-click data collection again, and now we'll configure it. So the server name, I'll just hit the ellipses, and it'll ask me to log on, which is fine. And the database name, when I pulled down my selection, it figured out it was MDW because of the properties of MDW. And the cache directory, this is where you want to store the information. If I don't enter one, which you really would if you were not doing this just in a test database. Otherwise, it'll store everything in temp. And we're going to collect the system data collection site statistics. And here's your transaction performance. And we're not doing any transactions really, so we'll just go system. And we'll go next, and we'll call finish. And she worked. Call close. Expand out data collection, and now you see under data collection we have usage, disk usage, query stats, and server activity. And if I look at any one of those, I just double click it and up she fires. So we can see the collection type, the collection frequency, and here's the schedule. It's going to data collection and upload on schedule every 6 hours. And of course that's changeable. I can come in here and change how I want it to do the uploads. Here's the input parameters if you're of interest. You can see the T-SQL that it's actually running. And it is, of course, it is running a SQL Server agent. I should have mentioned that. I've got the SQL Server agent running. If that's not running, it will not work. Over here, my uploads page, this is where she's doing the uploads again every 6 hours. And we'll say OK to that one. Here's my query stats. Same thing, query stats include the system databases, and we're going to collect and upload on a separate schedule. And again, it runs as SQL, retain data for however long, indefinitely, 14 days. Here's my uploads. Every 15 minutes, and of course I can change that, and I'm not going to. I'll say OK. Server activity. Okay, so collector type, frequency every 60 seconds. So generic and performance counters, collector type. And here's your parameters. And you can come down and take a look at this and see that she's doing a lot of work. Again, as agent, retain the data. Here's my uploads every 15 minutes, upload schedule. We'll say OK. And now I can, if I right click this, I can collect and upload now. So this is the manual process, but once again, we're just not doing anything with this database, so you're just not going to see much. What you really want to do is take a database, even a test database where you're actually going through and designing and working on some stuff, where you're running queries against it, and enable this and watch it collect the stats. So now I'm going to go into data collection. I'll right click that, and if I come into reports, management data warehouse reports, I'll look at server activity. And nothing surprising in there. We just aren't doing anything. But this is an example of the report that she outputs. Data collection, right click, reports, disk usage. Here's your disk usage of the databases that we have. And finally, query stats. So if we were doing a lot of activity, we would show top queries by total CPU. And here again are my different queries. See, I can come through and look at the duration of the queries, total I/O. To me, this is fairly impressive stuff. And you see this timeline. If you've ever worked in Project Server, that'll look real familiar to you. So here's the timeline that I can move across on this and pull in different timelines and take a look at the information. Remember, the different information is uploaded at different times. So, you're going to be able to see it come through. This is really an excellent management tool. Again, it has an impact, particularly it does collect just lots of data. That's why it's called a data warehouse. But it's a really super tool, and it's one you want to investigate and become familiar with.